Hello, thanks for joining me. Well, today I'm going to install a collet chuck. It's an ER40. There's a lot of different kinds of collets out there, but the ER collets have a pretty significant advantage. They tighten up in front instead of with a drawbar, which with a collet nut, and that allows you to use the bore in your lathe. In other words, stock will go through the collet and through the bore on your lathe. They do have collet, ER collet chucks that slip in. They've got a taper, and they use the taper in your spindle bore to hold the chuck, but then you lose the advantage of being able to put stock through it. So anyway, that's what we're going to do today. Let me show you what I got. Okay, here's what I got. ER40. Isn't that pretty? They look like they're well made, dirt cheap. Got them from All Industrial, and they didn't pay me for advertising. But they gave me a really good deal on these. They may be good quality, they may not, but we're going to see. Here's a chuck. I think I bought it on eBay. I'm not really sure. I can't remember. But it's got a standard collet nut. And from everything I'm reading, the ball bearing chuck, I think that was about 25 bucks, 30 bucks. Makes these collets clamp much better. The way the ER collet works is the collet hooks into the nut, just like that, and that's makes it tighten down on your stock. But the advantage to it is it goes clear through. But I've got to make a faceplate for that, and that's what we're going to do today. And here's my faceplate. I don't know what that came from. It's threaded inside. I suspect it was a slide hammer. I don't really know. I got it from where I used to work. Anyway, that's what we're going to use for our faceplate. Oh, that's just about perfect. After I've surfaced both sides of that, it'll be about the same depth as my spindle there, the threads on my spindle. And I'll waste off probably that much of it and leave a little donut on the back. And part of it will go inside that chuck. The first thing we got to do is surface both sides and then thread the hole and mount it on the spindle. And then the rest of the machining will take place on the spindle. Maybe a little fast for this diameter. Let's see what it does. I'll probably have to slow it down. Get my direction of feed backward. Here it goes. It may stall the lathe. Well, it's going to make a mess. And it's going to take a while. That's 30 thousandths. I think that's about the maximum my lathe can handle at that speed. Yeah, I did a good job. Okay, this procedure we're going through here is the same progression for any kind of faceplate, for a lathe. You basically mount it to your spindle. Well, that's tight, but it fits. Basically, the first thing you do is face it off, mount it to your spindle, and then you shape the faceplate to fit your chuck. When you machine it, when it's mounted to the spindle, you end up with everything concentric and no run out, or hopefully no run out. So now we're going to bore this to 1 point. This is an 1 5/8" spindle, and the root diameter of the threads is 1.49. Okay, I'm going to do a little math here. I'm heading towards 1.49. Okay, for right-hand threading, when the lathe is rotating forward, which is, I got a screw-on chuck, so I've got to rotate, keep mine rotating that direction. But in that direction, for right-hand threads, the tool always has to go in. For left-hand threads, it goes out. I can angle my compound this way, or I can angle it with the handle facing this way. To me, it's better if it's facing that way, because the handle sometimes interferes with the chuck on my compound. But to get the angle set right, I have no indicator. So I've set the compound at 90 degrees, and I've got a scale that goes halfway around. So I got 90 here and 90 on the back. And I'm going to make a scribe mark right here at 90 degrees. I'm going to make it fairly deep because I'm going to reuse it. I got bluing on it, but that bluing will wear off, but I'll still be able to see it. Now I can set my compound at 29.5. Technically 30 is what you would cut threads at, but it's recommended that you cut them at 29.5. Some people don't like doing it this way because you got to reach across, but it's really pretty easy to reach. Reset my tool post parallel to the bed. Right there. See, for 8 threads per inch, my lever has to be to the right. There we go. And this shift lever needs to be in. This every lathe. Okay. Now I need to be in back gear. I got my lever in the wrong right side. It's the other right side. There we go. Now I'm set up for 8 threads per inch. Most lathes have a 3-position selector here. The south bend works, or this model of the south bend works a little different. It's usually the center position will be the half net, which is what we're going to use for the 8 threads per inch. That'll be this right here. Now we're going to check, see if we're going the right direction. Remember I said in toward the chuck. Okay, we're good. I think this tool is the right height, but it's good to double check it. When you're doing internal threads, you need to go to the outside of whatever you're turning. Well, this is one way to do it anyway. Put a straight edge in there, and if it's vertical, then you're on center. Could go up just a hair. Now I want to touch off right here. I'm just barely touching the surface there. Okay, I just scribed a line there. Now I want to reset this dial to 0. Now, every pass, I will move this ahead, retract, and then put it back on 0. And all feeds will be made with my compound for each pass. Okay, I've got my compound set about 15 thousandths deep, and we're ready to make the first pass. Actually, I think I'm going to speed the feed up just a little bit. Speed the speed up. When you're cutting threads, you need it fast enough where you can react, slow enough where you can react. But higher speed will give you smoother threads. Let's go one more. If you're inexperienced at doing this, definitely go with your slowest speed. I'm watching this threading dial right here. Even numbers can throw in on any mark. Odd numbers will throw in on one of the 4 short marks or 4 long marks. I'm going to go with any mark. And this is why slower is better too, because you can hit the mark. I just screwed up. It's too fast for me. It'll be all right, but I just disengaged before I was all the way through. Okay, let's do this again. Now I want to go 1 turn in, retract, go back to 0. Increase another 10 over here. Wait for my mark to come around. Engage. One turn in, retract, back to 0. Another 10. Okay, as I get deeper, this 10 thousandths needs to become 8 or 5. I'm going to go about 8 on this one. I'm going to try speeding it up again. Okay, if you've made your bore size correct, when the threads get sharp, you'll be close to where you need to be. I'm going to go one more pass, then we're going to check the threads. Maybe two more. Okay. Hopefully I didn't go too deep. It's a good idea when you're cutting threads, the point of that thread will have a burr on it. So it's a good idea to carefully take some sandpaper to that, emery cloth. Now before I took this off, I had this ready to cut another 5,000, so it's all set to go if I need to go deeper, which I suspect I will, but you never know. Yeah, it's tight. I think one more pass will get it though. All right. Okay, look at this chuck. See that unthreaded portion? We're gonna have to cut that in a minute after I test fit. If it fits good, we'll cut that counter bore, whatever you want to call it. It's just a hair tight. I might want to go one more pass. Boy, that's why you put the board on there. I think I'm going to leave it. So now, see there's an unthreaded portion on the spindle? Pretty sure that's 1 5/8. 1.625, dead on. So that's what we're going to aim for on that, if you want to call it counter bore, unthreaded portion. Okay, replacing my threading tool with my boring bar. And I've got my lathe back out of back gear without the spindle engaged. I'm going to cut that recess. Probably a good idea to set a spindle stop, I mean a carriage stop. 1.625. Whoa, what about that? Right now, this is going to be flipped over, and that's the part that goes up against the spindle register right here. So, but that's really thick, unnecessarily thick. So we're going to take part of that off. In other words, it'll look like this over here. This is what we're cutting right here. I'd like to end up with it about a 1/2 inch thick, but then we have to account for what's inside the chuck. And there'll be, oh, what is that, 1/8 inch inside the chuck. I'm going to allow 2/10 inside the chuck. So we got to take down part of this, flip it over, and then we can finish the other side. Okay, this exact thickness doesn't really matter. I was going to shoot for 700 thousandths because 2/10 would be inside the chuck, and that would leave me a 1/2 inch. But I'm going to quit right there. That's pretty good. That'll leave plenty where I can countersink my or counterbore my socket head screws. Let me clean up this mess, and we'll flip it over and start machining the fit and the diameter of it. One very important thing here I forgot. The ledge on your spindle is slightly rounded, kind of like this is rounded here. So you got to cut a little chamfer on that inside edge. I've got my compound set at 45 degrees. Doesn't need to be a huge chamfer, but you got to have something there. Otherwise, you just won't seat up against the register. Okay, let's see if this thing fits. It's super important that that plate sits up against that ledge there. Otherwise your chuck won't be true. Now we're ready to cut it down to that diameter, and then take a ledge off it so it fits inside of that. Okay, I ran my tool up against the perimeter of that, the diameter, reset my dial to 0, and then I measured the two and did the math, and I need to take off 410 thousandths. Well, I slowed it down. I'm having a little bit better luck in back gear, trying to break chips. Well, according to my calculations, I'm about 5 thousandths shy. Well, that looks pretty good. And it is about 5 thousandths shy. I think I'll speed it up, take one more finish pass. Okay, I've run my tool up to the outside diameter of that. Now I'm going to measure it. .940. 3.940. Wrote that down. Now I'm going to measure the inside of my collet chuck. 2.836. There's the outside diameter, there's the inside diameter of my collet chuck. That's the difference in diameter divided by 2 gives us the radius we got to take off. So that's about a ½ inch. 5.52. I've got the dial set back at 0, and I want to go in 200 thousandths. So there's 200 thousandths. I'm going to set my carriage stop right there. Now this is probably the most critical part of the whole thing, because that ledge has to fit right in there perfect. Otherwise you won't be concentric. Okay, I'm down to going where I need to go 10 thousandths more, but I'm not going to do that. I'm going to go 5 and then try it. This is super important. I think that's about as good as I'm going to get. And now, I can put my not my dividing head, my indexing gear on the end of the lathe, or I can take this off and use a transfer punch. Oh, it's perfect now. I think I'll use a transfer punch. I got a little off on my holes and I had to make them oversized, but they'll work just fine. See where I came through the edge there? And this one I went into the shoulder there. Probably should have done it on the lathe with my indexing gear. I don't know how I got off so far there, but it'll work just fine. Cool. I like it. I guess I could have threaded the back plate and put clearance bolts in there, but I just thought it'd be nice to have that smooth. think it's meant to work either way. Well, there it is, all done. Let's see, I don't have any machined drill rod or anything to really give it a good test on. If I need to hold that, I can with a pin. I just put it in back gear. That looks straight. Let's put an indicator on it. Of course, this is cold, or yeah, it's cold rolled steel, so it's not going to be dead on. According to that, it's 1/1000th off. I can live with that, but I suspect that's that cold rolled steel. According to everything I'm reading, when you got the ball bearing chuck, it doesn't take much torque to make it tight, a ball bearing nut. One-thousandth out there and about 1.5 there. That's not too bad. Be interesting to know whether it was my plate here or if it's the collets. That's pretty darn close. And these collet nuts are designed to break the collet free when you're undoing it. Like right there, it's tight. Now it's free. Well, that about wraps it up. It's been quite an adventure, a lot of chips. Thanks for joining me, and be sure and subscribe. Look at that.